All right. Moving on to chapter 4 today. So grab some paper, we can take out some notes, maybe take a few notes. Pretty simple little thing about matrices. Matrices is just a way to show some data. It's in an array, and I think you'll find this section of not too bad this morning for a Monday. So here we go. So we're going to use those matrices to display some data. You see it all the time. You walk into Wendy's, what do you first do? You look up at the menu, and that is in an array or a matrix. You go into Taco Bell, you look up at the menu. When you pull up your computer and you want to check your grades on Canvas, what are you looking at? A spreadsheet that is basically an array. I have lots of spreadsheets myself. I'll show you one that's one of my favorite ones that I have, and that is my bike miles. Hopefully you'll be somewhat impressed by my wonderful biking. Okay, so here it is, 2020. I've ridden 2,658 miles. So there's all the dates and the times I've ridden this year. On 10/18, I rode 20 miles. So I have it separated out. And here's other years. So then 2019, 2018. So I started keeping this log back in, this is basically an array. I started keeping it in 2009, and since 2009, so roughly almost over 10, I've ridden 23,039 miles. How about that? That's some good legs right there, okay? So there you go. There's my array, and I've kept that going all this time. So little brag on myself, maybe too much, but not, hopefully you don't, think anything of that. But see, certain years I've ridden a few more miles than other years. So this was a pretty good year, 4,000 miles. So plugging away for this year, probably getting close to the end because the weather has changed a bit. And I don't really go out too much when it gets too cold, but I'm hoping maybe to sneak around 3,000 miles. I can get another 350 miles in, but who knows? But that's just my array of my miles. So those are what we're talking about, just something like that. All right, so there's a matrix, dimensions. We're gonna have entries, just a couple of terms there that'll come to you. So this is a basic type of an array, okay? Nothing real big special here. Now the matrix or the array is really just the data parts, okay? So this guy right here has some rows and columns. So it has 1, 2 rows, it has 1, 2, 3 columns. So this always, we're gonna name that row by column. So this is a 2 by 3. So rows, columns, always, that's one of the major things we need to write down today. Rows by columns. And I always think of it as RC Cola. If I get mixed up, I know RC. I used to drink that when I was a kid. I think it's still out there. Has anybody ever seen it? In the Giant Eagle line, I think they still have it. I saw the other day that Tab is no longer being produced. And people were upset about Tab. You ever drink that? It was kind of the first diet pop ever, and it was nasty. It tastes like water that dripped off the roof, but some people liked it. But it was a diet pop. But now there's so much diet pop out there that it doesn't matter. So these also have an address. So the address is also row by column. So just like you still remember, do you remember your first address when you went to kindergarten? I still remember mine. Okay, 9917 Bellhaven, Greentown, Ohio. That's where I lived when I went to kindergarten. Because when you went to kindergarten, you had to know your address. In fact, I think you probably still do. And if you think about it, you probably, unless you're living in the same house, some of you might still be. But I remember that house, okay? And I remember my address. Well, address here is going to be row by column also. So this would have the address row 1, column 1, wouldn't it? This would have the address row 2, column 2, 22. This would have the address row 2, column 3. Does that make sense to you? So each of these little spots have an address. Just like if you play Battleship, what do you go? B9, you go look, right? Or even bingo, okay? So it has address. Or the spreadsheet that I had up there. Excel, one side's letters, one side is numbers in Excel spreadsheet, okay? So think of it that way. So the dimensions are row by column. So this guy right here is 1, 2 rows, 3 columns. So this is my 2 by 3. Remember, RC colon, 2 by 3. And each one of these spots is called an entry. So we entered a data. Let's go ahead and answer a couple questions, see if we can go through there. So this is kind of what I already talked about, the address. This would be row 2, column 1. Over here, if we were finding the address here, it would be row 2 and column 3. So matrix A, row 2, column 3, that's what this matrix would be called. You can call them anything. This one we can just call by letters. So how do we feel about that? So row by column, and the address would also be row by column. All right, here we go. The prices of different, what is the dimension? What is the dimensions of this? Now, when you're looking at it, it's basically a menu, okay? You're looking at just the numbers. So how many rows do I have there? How many rows do I have? 3, and how many columns? So this is pretty simple. It's a 3 by 2, okay? Tell me, are there any spots that the cost is $5.25? What would that dimension be? We're gonna call this matrix A again, it doesn't matter. So this would be matrix A is a 3 by 2. So what's the address of $5.25? It would be A what? Row 3, column 2. How are we feeling there? Is everybody okay? Questions at all? All right, move forward there. What does 3, 2 represent, which we just talked about? Row 3, column 2, and that would be $5.25. All right, here we got one. See if you can answer these quick questions here. Give you a second. Mike, what you got going on back there? Getting after it? Are you winning? Oh, you're not. Your fingers are going pretty fast. Oh, you're typing an English assignment.
Yeah, actually.
Oh, boy. Remember row by columns? How many rows are in this big matrix M? How many rows do we got? We got 3. So M is a 3 by 4. Folks, on a Monday, that's pretty easy stuff, isn't it? Come on now. Okay. What is the entry at M32? So that'd be row 3, column 2. The entry there is 11. Right here, 11. Do we have any entries with 0? So you're going to say M something. Give you a second yet. Looks like we have 2. So there's 2 addresses there that I'm asking you to find where M is 0. What do we got? Row what? 1, 4. So M 1, 4, that would be this guy right here, and M 2, 3, which would be this guy right here. How do we feel about naming them and also the address? Everybody feel okay? All right, you're right there, Jess. Hold your ears. How about them Cleveland Browns yesterday, huh? Was that like 5 and 2?
Well, that was great.
People's Jones, that was a pretty good catch in the corner. I didn't, for a Michigan guy. Yeah, Urban Meyer said that Peoples Jones was a top 10 pick in the NFL draft, just no one knew it because Michigan didn't know how to throw the ball to them, so maybe there was some Michigan fans. Are there any Michigan fans in here? Oh, that's good news. Yeah, here we go. Now, we're gonna add these and subtract them also. Now, to do that, they must be the same dimensions. Now, this might be one of the easiest things we do all year right here, okay? So if they're not the same dimensions, you say you can't add them, okay? If they are, you're gonna add like spots. You know what? This is so easy that if you're messing around your cell phone or not doing what you're supposed to, you probably will still get this right. What do you think? That's a possibility. All right, let's take a look. Something happened there to my, let's see if I can, fix that a little bit. Oh, looks like it's gone. Let me pull it down. Oh, there it is, entry. All right. Can we add W and Y? Well, let's look. What is W? What size is W? Oh, my goodness. It is a 2x2, isn't it? What size is Y? Also a 2x2. Are they the same? Certainly. So now we can add those. And folks, you are going to love how easy it is to add these. We're going to make a new one, okay? Let me slide this over a little bit. So I'll put him right down here. And he is going to go right here. Okay? And we're just going to add like spots. Look. 3 and 1 is 4. How many of these you want on the quiz? A bunch of them, right? -2 and 4 gives me 2. 1 and -2 give me -1. 0 and 3 give me 3. How about that for them apples right there? Woo-hoo! Want a whole bunch of those, don't we? Yeah. I don't know, what do you think? 15 of those on the quiz, 1,000 points each? You all right, huh?
Yeah. Sure.
Is there anything else we could add up there? Are there any other of those we could add up? We could add X and Z. We could also subtract too. So instead of adding, we just say negative. Now be careful when you get a negative. What does that mean? Yeah, it means a positive, so. X minus Z, can we do it? All right, see what you can do. See how far you get there. X minus Z. It's minus now, so we're going to get the same size. This is a 2x3, adding or subtracting to another 2x3. Subtraction. All right, so 4 minus 2, I think are 2. We're going to have 7 minus a minus 2. I think we get 9. We're going to have 2 minus 3, which gives me -1. We're going to have 5 minus 1, which gives me 4. We're going to get 1 minus 0, which would be uno, and -1 minus 4 would give me -5. How did I do there? Did everybody get about the same as I did? Folks, I'm not going to belittle this stuff. It's pretty easy, isn't it? Compared to where we've been and what we've been doing and what we're going to do. But it's going to get harder. Multiplication is much harder. We're going to be able to use our calculators though. But to do it manually is time consuming. We're going to solve some systems of equations by using matrices here, which is pretty slick. How are we doing about adding, subtracting, and understanding matrices dimensions? RC, row by column. Can we? X and Y, can we add those together? No, we cannot. Not the same, okay? Your X is a 2 by 3, and your Y is a 2 by 2. Better known also, 2 by 2 is a square matrix. 3 by 3 would be a square matrix. Okay, if you see that come up. So no, can't add those. Move on to the next problem. How many of those you want on the quiz? You got a bunch more, huh? B and D, can we add those up? I'm not gonna make you do it. Just tell me yes or no. Yeah, is everybody good? Move on to the next thing and the last thing today. Just tell me this. Can we add those? Can we subtract those? Yeah, we could. All right. Scalar. Sometimes we'll have a scalar out in front. Nothing big deal here. Think of it as distribute. So we're going to say P plus R. But what are we going to do to P before we add that to R? We're going to multiply every element or every entry by 3. Okay? Well, first, can I add those? Is P and R the same? How many rows are there in P? 3. Okay? So it's a 3 by 2. 3 rows, 2 columns, RC, and this is a 3 by 2. So first I'm going to multiply 3 over all those elements. So I'm going to have 9, right? 3 times negative 6, 3, 0, 6, and negative 3. And I'm going to add that to R. And I'm going to get my new one. So I have 9, I'm going up to R, 9 and 1 give me, of course, 10. Negative 6 and 4 gives me negative 2. 3 and negative 2 give me uno here. 0 and 3 give me 3. 6 and 0. Looks like I'm getting 6. Negative 3 and 4 gives me 1. And there I used a scalar and did the same stuff. So that scalar is what? Just kind of like distributed, isn't it? Woohoo! Yay! Yep, so the Browns look good, the Buckeyes look good too, didn't they? Did you fence anybody over the weekend?
That's the matter of fact, I did, yeah.
Can we do R and P? Can R and P be added or subtracted here? Yes. What do we got to do to R first before we do it? I'm not asking you to do it because this is simple, all right?
Yeah.
B and C, can we add B and C? No, can't. All right, some of these properties hold true. Nothing real important here. We have the commutative, we can change the order, associative. Okay, you can distribute, additive. There's an inverse, but we'll talk about those. Our calculator is going to give those to us. I have a little short quiz here, but no one really wants to do that. So let's just get right to a couple of problems. You can submit this on Canvas and be done before you leave here. You got about 15 minutes to easily knock this bad boy out. Thank you much. Have a good day.